Alright, so hopefully watch the previous video on the difference between deductive reasoning and inductive reasoning when we're doing logical arguments. In the following lessons, we're going to focus on deductive reasoning, alright, and understanding when it's valid and when it's not valid, and then get into fallacies. Alright, fallacies are the different types of invalid arguments. Alright, so, and we do that with deductive reasoning because inductive, you can't really call it valid or invalid. It's more based on probabilities and patterns. All right, so it's just I've noticed this pattern. This is my reasoning, so I think this is going to happen. And it happens or it doesn't happen, based on probabilities. Valid reasoning, though, deductive reasoning is an argument with a premise and a conclusion, and there's some type of proof in there that makes it true or not true. And so we're going to look at the cases where we have valid or invalid arguments. And again, we talked about Venn diagrams. Venn diagrams are a good way to determine if an argument is valid, logical, or invalid using deductive reasoning. All right. So again, when we do these, we draw the circles. There will be regions of the circles that's empty. All right, that happens. And again, you have to be careful with negations, meaning things that are not included, because those are the ones you have to be careful. Remember, we're not in a circle. We're not in that circle at all. All right. So our first type of arguments we're going to look at is all A, which would be the premise, then B has to be true. All right, all A are B. All right, so examples of deductive reasonings of these types, and we're going to determine if they're valid and invalid, kind of using, and most of these hopefully should make sense to you. All right, again, it's sort of a logical assessment. All right, so the first example, again, it's a bit of a nonsense example, but it's getting you used to what we're determining here in terms of validity and non-valid arguments. All right, all ghosts are restless. Casper is a ghost. Those are my premises. Casper must be a restless spirit. All right, that's my conclusion. So we've got ghost and restless spirit. So we've got ghost circle. So I'm going to do that G and a restless spirit. So I'm going to do R for restless spirit. If you're a ghost, you're in the ghost circle. All ghosts are restless spirits, so every single one of the ghosts lands in this region, right? They're all in this region. None of the ghosts land there. And so, all right, all ghosts are restless spirits. Casper is a ghost. Right, so Casper lands in the ghost circle. All the ghosts are in this wedge here, so therefore he's also in the restless spirit circle. And so that's true. My conclusion is true. My premises were all ghosts are restless spirits. Casper is a ghost. And it was a very logical conclusion that if Casper is a ghost, he has to be a restless spirit. So that's a valid argument. All right, next example. All lilac bushes get flowers during mid-spring. My bush outside, the bush outside my house, got flowers during mid-spring. Therefore, it must be a lilac bush. All right, so we've got bushes that flower in the spring, and lilac bushes get their flowers in the spring. All right, so we've got lilacs. I'm going to do that. Lilacs. And this circle represents flowering bushes, and we'll just assume mid-spring. All right, they're all mid-spring. All right, so if it's a lilac bush, all lilac bushes flower in mid-spring. So if you're a lilac bush, you land here. There's no lilac bushes that don't flower in mid-spring. All right, so nobody's in this area for lilac bushes. All right, so then the next statement is the bush outside my house had flowers. All right, so that's the premise. So there's two premises. All lilac bushes flower in mid-spring. My second premise is the bush outside my house has flowers mid-spring. So the conclusion I drew is that it had to be a lilac bush. This one, however, is false, because because what we're given is that it flowers a flowering bush. Well, is it a flowering bush that's here, or is it a flowering bush? All I know, it's in the flowering bush circle. I don't know if it lands in the lilac circle. There's no proof of that in the statement, and so this is a non-valid argument. Non-valid. Not non-valid. So it might be true, might not be true. All right, next example. All physicians have a college degree. All right, so that's premise one. Molly is a physician. All right, that's a premise. Therefore, Molly has a college degree. My conclusion. All right, so we've got physicians and college degrees. So I'm going to do a circle for physicians and people with college degrees. All right, if you're a physician, you have a college degree. So all physicians land here. All right, none of them land outside of the college degree circle. Molly is a physician. If she's a physician, she lands in the physician circle. All physicians land in the college degree circle, so that means Molly does land here. And so Molly landing here means she's in the college degree circle, so the conclusion is true. That is a valid argument. She lands in the correct circle, the correct part, the middle wedge. All right, well, what if we flipped it around? All right, so the same first premise, all physicians have college degrees, but this time my second premise is Molly has a college degree. My conclusion is Molly is a physician. Well, let's see if that's valid or not. All right, so I've got my physician circle, my college degree circle. Again, all physicians land here. If you're a physician, you're in the college degree circle. Nobody lands outside. No physicians land outside the college degree circle. All right, so we know Molly has a college degree. The conclusion that they were in the physician circle. But this is not valid, right? All we know is that she has a college degree. She's in the college degree circle. I don't know where in the college degree circle. She could be here or there. All right, she could be a physician. She might not be a physician. So the conclusion is not valid. It's not a good argument. The next one. All band members get backstage passes. Tammy does not. So this is a negation. She's not in possession of a backstage pass. So the conclusion is she is not a band member. So this is what we mean by negation. You have to be careful. Where do you land? That's what we're trying to figure out. All right, so we've got our members, band members, and we've got our backstage passes. All band members get backstage passes. So that means if you're a band member, you land here, right? You don't land there at all. You're in the backstage pass group. All right, so what do we know about Tammy? Tammy does not have a backstage pass. And so Tammy's here. She's outside of the outside of the backstage pass circle. All of the band members are inside the backstage pass circle. And so since she's not there, she's not a band member. And so the argument is true. All people who don't have backstage passes cannot be band members. So that's valid. All kids like so next one. All kids like hot dogs. Sam likes hot dogs, therefore Sam is a kid. Alright, so premise all kids like hot dogs, which again may or may not be true. Sam likes hot dogs, therefore Sam is a kid. Alright, let's see if this is a valid argument. Alright, so we like hot dogs. Hot dogs. Kids. If you're a kid, you like hot dogs. All kids that like hot dogs land in here. Sam likes hot dogs. Well, liking hot dogs, there are two spots. He could be either here or there. Doesn't necessarily mean he's a kid, right? He could be adult likes hot dogs. And so that is a non-valid argument. All right, the next couple of arguments we're going to look at are specifically if-thens. All right, so looking at if-then statements for deductive reasoning and determine if they are valid or not. All right, so if the temperature is below 0 degrees Fahrenheit, then class will be canceled. All right, the temperature outside is -4 degrees Fahrenheit. Therefore, class will be canceled. All right, the hypothesis is there are actually two. There are two hypotheses. There is the hypothesis here. All right. The very first line is the hypothesis. If the temp is less than 0 degrees Fahrenheit, then class is canceled. The temperature is, so that's premise 1. Premise 2 is the temp is 4 degrees Fahrenheit. So those are my two hypotheses. The conclusion then was class is canceled. valid or not valid. Well, that's a valid argument, right? If you're, again, this one is, when the if-then statements, it sometimes makes a little more sense because of how it's concluded, right? So we have degrees less than 0 degrees Fahrenheit, canceled class, all right? We're canceling class if we're below. So all canceled classes land inside the 0 degree region. -4 degrees is less than 0 degrees, which puts me here. If that puts me there, then class is canceled. All right, valid argument. All right, the second example of this. If you exercise every day, then you will live to be 100 years old. Martha is 100 years old, therefore Martha exercised every day. All right, so again, there's two hypotheses. If you exercise daily, you live to 100 years. Martha, so that's premise one, our hypothesis, right, the first part of the hypotheses. Martha is 100 years old. What's the conclusion? Martha exercise every day. Valid or invalid? Well, this is an invalid argument. Alright, it's actually invalid for two reasons. It's a fallacy, right, because this is not always true. And it doesn't say everybody who's 100 exercises, and so it doesn't fall inside the all circle. Alright, so it's an invalid argument. And that should make sense that one's an invalid argument. And so this one has more to do with the logic of the statement is incorrect. So this is more going to be a fallacy, which we're going to talk about fallacies in the next set of notes.